So these are common methods that you can use with ArrayList object, and of course you can add elements just like we did over here. But if you'd like to specify a position where to add the elements, like for instance if I add position 0 because I know that the element with the index 0 already exists, and if I run my code, then if I run it, you can see that 4, 5, 6 is inserted before the element at position 0. So just like with array, indices inside ArrayList begin with 0. It's 0-based indexing. So here you can use add to insert elements in arbitrary positions inside your ArrayList. So that's just another form of add method, another overloaded version of it where you can use both. Clear will remove all elements. Contains will verify if the object exists inside your container. So it will just sequentially search through the container to identify whether the object already is present in the list, so you can find out if you need to insert it or not. Get retrieves element at the specific position. You can also, similar to contains, you can find out what is the index of an object if it's present. Okay, you can also check whether the container is empty. You can remove element at the specific index or by specifying its object reference. So object references will be compared and the element can be removed. At a specific position you can set specify the index, and you can set the object to something different. Okay, so you can update. This is an update of an existing element. Size, of course, returns the size of your container. Size can be 0 if container is empty, and you can also convert your array list to primitive Java array. So just continuing examples of using ArrayList, very similar to what we did in our own sample using LinkedList and ArrayList, but these are examples specific to ArrayList. And for debugging purposes, there is a built-in conversion of ArrayList and other Java containers directly to string type. So this is primarily for debugging purposes. You probably don't want to rely on this type of output in your actual software programming, but it's just available that you can quickly display the result. So when we use the loop, we can decide how to print, in what format we want to print everything, but here is just a quick display of all elements inside your collection. So this is an example of you using remove method, which removes an element based on the string value, because codes is a collection of strings, and this version of the remove will remove element at a specific index. So that element with this index will be removed. So this is an array list of type integer, as we used right here. So 1, 2, 3 is the result, and this is the output. If you just print line this collection, you just get this very simple display. Again, very useful in debugging. So list processing, and we use our list interface with both LinkedList and ArrayList, is that we can, the list processing or list operations include searching for items. We can sort the list just like we used to sort elements of an array. We can sort the elements of ArrayList and LinkedList. We can insert items in the list, and we can delete items from the list. So LinkedList class is another type of data structure that organizes the list in a form of linked nodes, whereas ArrayList uses internal Java arrays to construct the storage for your elements. So this is the constructor type, and the methods of linked list are kind of similar, but there are a few other methods such as speak, offer, and poll, which are similar to contains that allow you to get access to specific objects at the beginning of the collection. But the rest of the methods should be pretty obvious. You can remove at the beginning of the collection, you can remove at the end of the collection. You can still remove specific index and specific objects size, and also convert the list to a primitive Java array. So this is an example of a linked list of strings, and just quite similar to what we did at the beginning of this presentation. Right, so you can use add first and add last, which will obviously grow an existing list at the tail and at the head of the list. And so these are pretty typical operations with a linked list type of data structure. Again, using for each loop to process the list elements, but remember the restriction of this loop is that you cannot remove elements inside the loop. For example, if I try to just go ahead and every time I iterate through this loop, if I say okay, codes remove, and I'll just attempt to remove an element at position 0. Okay, just remove whatever happens to be at position 0, just remove. If I attempt to do something like this inside the loop, you will see that this will create a problematic situation. It says concurrent modification exception. The concurrency here means that there is a loop that is trying to process this collection linked list of strings, and suddenly there is some sort of foreign manipulation of this concurrent manipulation or concurrent modification. This is not allowed for this type of loop, and so you get this type of exception, concurrent modification. So if you experience something like this, it's a possibility that you had a loop which may not necessarily do it right here, but it could call another method that gets access to this collection, which decides to remove an element, and this will be your exception. So that is just a restriction of this type of loop. Remember, we discussed an idea of an iterator object, which would allow you to create an iterator and loop and be able to safely remove elements from collection in the middle of iteration without this type of exception. So this is another example of removing at the beginning, at the end of the container. Again, this is like printing the results, and the removals with linked list return a reference to an element that is being removed. So essentially you sort of like remove it from the list, but you still retain a reference to it if you want to, and you can just skip this part and remove without retaining any references. Then the object retained by your collection will be just removed from the collection.